Good afternoon, everyone. We are studying the Geotechnical Engineering 2 coursework. This is the NPTEL coursework in which we are in the week 8, where we are going to study some aspects of earth pressure theory. We have also read the earth pressure theory during the last class. In this class, we carry forward those concepts. Specifically, during this class, we are going to solve the problems associated with the earth pressure theory. Before going into those aspects, those contents, first of all, we start with a quick recap of the last session. But before that, I will want to add some instruction. First of all, my name is Sumit Kumar. I am PhD research scholar at IIT Islamabad. This coursework is taught by Professor D.N. Singh sir from the IIT Bombay. And this coursework convey you the application of the different aspects which you have gone through during the course of geotechnical engineering 1. Over here, you understand that how the different practical implementation of the soil mechanics is applied in the field in one way or the other. What are the challenges and what are the different remedy which we provide for those aspects? First of all, we have understood the shear strength during the earlier classes with the different tests and the different mechanisms. We have solved the problem associated with that. Currently, we are going through the earth pressure theory in which we have understood the theory and some of the question during the last class. In this class, we are going to move ahead with those concepts and going to solve some problem. Okay, some important instruction for this class and all of the class that this is a 13-week, 12-week series, and there may be one additional week we could add for the quick revision of the entire concept during the last class. But what the most important thing which I want to convey you that this class is going to take place from 3 to 5 every week. And those who are attending online or those who are going through the YouTube, please go to through these classes. And if any question you have with you, you can ask me during the live sessions. I will try to answer as per my efficiency. And if any more doubt could be there, you could also convey the message through the forums. Rightly said. Okay, and one important thing in this class is going straight away for the 2 hour, in which if due to any case some network problem arises, the connection goes out. Please be stay in the meeting. I will rejoin and take the class forward from there only. So please be patient for such situations if such situation arises. Okay. So now I can start. And first of all, I will try to quickly recap the session which we taken during the previous class before going with the new content for better understanding of the aspects which we are going to deal with. Okay, so we have understood the earth pressure theory. Over there, the things which are shown on the screen, that is the Coulomb, Rankine, log spiral, everything we come across. Well theory. So we have understood that how the earth pressure theory get built up. First of all, we have understood the earth pressure theory in relation with the earth pressure at rest condition when the soil is not having any pressure from like the wall is not moving toward the soil or neither the soil is moving away from the soil. The soil and the wall remain at their own position without disturbance. Is the condition when we say that the wall at rest. Similarly, the active earth pressure to passive earth pressure, we what we understood we have gone across. So these are the main three things. When we talk about the earth pressure theory, we talk about the backfill and the retaining wall. Basically, these two things when interrelate form the different types of pressure upon each other another and leading to the earth pressure theory in a real sense. So we have understood that how the retaining wall, how the backfill apply the force on one another. What are the things which we could gather, which we could understand when we talk about these concepts in a way or the other. So those things we have discussed. Okay, so over here the image is also presented to you. Over there the wall and the back hill has been represented clearly, and as it has been seen over here that the backfill, the soil filled behind the wall is said to be backfill, and the retaining wall ahead of it is the retaining wall. Similarly, the design of retaining wall is discussed the types of wall movement that the wall is moving away from the backfill, the active earth pressure condition, and the wall is moving toward the backfill is the passive earth pressure condition we have discussed. Wall at rest and the active earth pressure and the passive earth pressure are some of the things which we have gone across and develop the understanding regarding the same. We also come to know about that how when the wall is moving toward the soil that is said to be passive earth pressure. We also understood that the force in the horizontal direction will be dominant when we talk about the passive earth pressure condition, while the force in the vertical direction is the dominant when we talk about the active earth pressure condition, because the stress applied in the horizontal direction is reduced due to release of pressure on the soil when the ball is moving away from the backfield. Similarly, in these images represent the same. And so we have understood the Rankine earth pressure theory. We have understood the interrelation to calculate the resultant force at the base when the earth pressure in rest condition, like 1 by 2 into K into gamma h square. We understood the coefficient of earth pressure is the ratio of horizontal sigma h by sigma v. And similarly, we understood the different interrelation to find the value of K during the earth pressure at rest condition. K is nothing but coefficient of earth pressure. When we talk about it in the rest condition, that is said to be 1 minus sine phi, where phi is the angle of internal friction, or mu by 1 minus mu, where mu is the Poisson ratio. It depends what are the things which we have with. In that order, we try to answer those things. We also come across the assumption that what we have assumed during the Rankine theory. So, with the assumption we have developed and the some conceptual clarity, and from as I have said earlier, the assumption are the very much important as we have analyzed ground surface as plane, no wall friction. This is not happens all the time, but these are the assumptions, and the wall moves sufficiently to develop the active and passive pressure condition, earth pressure condition. Most critical surface plane is in reality it is slightly concave, but when we talk that it is a plane, the most critical shear surface plane. Similarly, the resultant and the normal shear force that act on the back of the wall is inclined at an angle parallel to the ground surface. So these are some of the assumptions which we carried out when we study the Rankine earth pressure theory. After that, as what I have discussed, the earth pressure coefficient as k not equal to mu by 1 minus mu, or 1 minus sine phi, where phi is the angle of internal friction, is we came across, and which is also written over here. Similarly, in the earth pressure in active condition, how we calculate the earth pressure at a specific location, or the resultant earth pressure in kilometer per meter, everything is mentioned over here. So up to here, I will leave the things which we have discussed during the last class. Now we will move with the new concepts and the new problem which we are going to deal with in the present class. Okay. So I think so. The quick revision is might be helpful for you, as this is the starting time of the class. So I believe that some people might may join later. So that will help you over here. That's why I try to cover those things. Now I will move with the new content so that you are now get the new concepts and the new things, the new questions, so that will develop the better understanding of the subject. Okay, let's go. So, what we are discussing about the Earth pressure theory, we will carry it forward. We have understood the Rankine theory, we have understood its assumption, we have understood the three conditions. But what we actually understood that the wall should be there, the backface should be there. But as we move over here, I will write something with the pen so that it will give you. See, this wall is repainted over here, the wall is there, and the soil over there is a backfill. I will also write so that afterward when I provide you the presentation file, one thing that what we are discussing is also shared with you. through the Google Drive link, which is already shared with all of you. And this video is also recorded, which will be shared on the YouTube so that you can go across. So see over here, when we talk about the active condition and the passive condition in the same case, over here for the active state in the wall, this is the wall, and this is moving away from the backfill. So when wall is moving away, it is the active earth pressure condition. Similarly, for the same condition, when wall is moving toward the backfield, it is the passive earth pressure condition. And in that regard, you can see that the value of horizontal and vertical stress act in one way or the other at the depth Z when we discuss. Okay, so see, one most important thing which we are getting from here, that the movement of wall toward the backfield or away from the backfield make it the passive or the active earth pressure respectively. So it is very much important that the wall movement ultimately result in the types of stresses which will be dominant in the horizontal or vertical direction is seen over here. As you see, when this wall moves toward the backfill, so there is a increase in the stress in the horizontal direction when we compare with the vertical direction. So over here, the earth pressure in the horizontal direction will be dominant, that with the principal maximum principal stress in the horizontal direction. Similarly, when this wall is moving away from the backfield, the stress on the soil get released from here, so the stress in the horizontal direction get reduced. So the predominant stress is in the vertical direction. So the principal maximum stress in that concern in the vertical direction with respect to the horizontal direction. So this thing is also related to the our sigma 1 and sigma 3, which we have discussed during the try Excel tests. Okay. And when we move ahead, as we are discussed, that when we talk about the distributing the active earth pressure, we have said that it is nothing but k into sigma z minus 2c root k as per Rankine. It is up to k. It is up to k minus sigma z, but when it is extended to the cohesive soil, it's become minus 2c root k as per Bell's theory. So at a specific point, when we are interested in finding the value of the stress, we came across the value as sigma at a specific point A, or the alpha is kz k into sigma z minus 2c root k, where k is the 1 minus sin phi by 1 plus sin phi or tan square 45 minus 5 by 2. So as we know, whether K is the active earth pressure coefficient or the coefficient of active earth pressure, or phi is the angle of internal friction, C is the cohesion, and gamma is the total unit weight of the soil. As you see over here, it is represented sigma z equal to gamma z into z, that is the stress at depth z, which is the value of the unit weight of the soil multiply up to that depth z, give the value as sigma z. And when some surcharge maybe over there, so that is also get added to the given gamma z. So its may be gamma z plus qs, as qs is acting on the backfill as a surcharge. And the failure surface of the active earth pressure is also seen from here. Over here it is see, you see that theta angle is represented, that is nothing but 45 plus 5 by 2, which we have discussed also during the last class. Now, similarly discussing the passive case, passive earth pressure condition, where sigma p equal to kp sigma z plus 2c root kp, where kp equal to 1 plus sin phi upon 1 minus sin phi, or that is also equal to tan square 45 plus 5 by 2. Kp is the passive earth pressure coefficient, or the coefficient of passive earth pressure. So you can see that. Now there is another case which we have not discussed, that at any point alpha, when we are interested in calculating active earth pressure and the passive earth pressure, so when the soil is at the inclination beta, So what are the earth pressure coefficient formula? That become also very much important. The first interrelation representing sigma A is the active case, and second, which represent Kp sigma z into cos beta, is for the passive, right? Okay. Over here, you see the interrelation is for the inclined backfill is cos beta minus cos square beta minus cos square phi by cos beta plus cos square beta minus cos square phi. Similarly, Kp equal to cos beta plus root under cos square beta minus cos square phi by cos beta minus cos square beta plus cos square beta minus cos square phi. So it is the coefficient of earth pressure in the active and passive condition respectively for the inclined backfill, where beta is the backfill inclination from the horizontal. Okay, I will not write. I have said it. You could write by yourself, and phi nothing but angle of internal friction. So in this manner, you are able to calculate the coefficient of active earth pressure. And there are many times these questions are asked to find maybe the total stress acting at the bottom. Over there, you calculate everything, and or there may be sometimes the question asked only to calculate the coefficient of active or the passive earth pressure for the inclined backfill. These types of question may be framed during the examination as well. So be aware and solve those type of problem. We will solve the problem on this concept in the today class only. Okay. Now you see over here, we also know about the Coulomb theory. So Coulomb theory represented the weight beta are what are written. We will discuss. And when we talk about the active earth pressure theory, we know that the resultant when we are calculating resultant, we say 1/2 into k into gamma h square, which is acting in kilonewton per meter at the h by 3 above the ground surface is represented over here. Similarly, for the passive as well, 1 by 2 into kp into gamma h square will be there. Now we are moving to our very important concept, that is the calculation of earth pressure below the water table. So in those cases, the earth pressure are estimated by the superposition of the following two resultants. So earth pressure due to the effective stress in the soil. So we calculate the effective stress whenever we are calculating sigma z, in which we multiply with k or kp respectively for the active and passive earth pressure. And the earth pressure due to the hydrostatic stress of water. The when we multiply k, we doesn't multiply in the water, but we add the pressure due to water is abruptly. So we will see those things as per question. When we talk about the graphical method, so if a backfill surface or the internal face of the wall are irregular shaped, or if there are the points or the lines acting on the backfill, the graphical method are used for the calculation of the earth pressure. One common method is the Kalman method, and it is a graphical method can be adjusted so that it can be applied using the computer programming. The Kalman graphical method presentation is also shown over here. When we talk about the earth pressure in the cohesive soil, so the Coulomb theory can be applied in cases of the cohesive soil. In this case, the assumption need to made regarding the coefficient of friction CW between the wall and the soil. Also, it accepted that in the case of the active pressure, the vertical failures are developed at the top of the wall due to the tensile forces that are generated at the depth. So if the crack is filled with water, then the hydrostatic pressure creates an additional pressure on the exemplified of part of the pitch. So those are the also problem associated with these types of things. Okay, now see the types of retaining wall we have. First is the gravity wall, second is the cantilever wall, third is the diaphragm cantilever wall, fourth is the anchor diaphragm wall. When we talk about the diaphragm wall or the anchored, they are the cantilever and anchor. They are the flexible walls, whereas the cantilever wall, gravity wall are not as flexible. Okay, now we are moving to the questions segment. And over here, we are going to solve the questions only for the next 1.5 hours. We will solve the many standard problems which are specifically asked in the many competitive exams like GATE and engineering services. With these problems, you can develop the better understanding of the concept which we have discussed till now. And as we move ahead, you see that your understanding of the things get developed very sharp. So over here, the question, first question is the earth pressure for the design of bridge abutment is taken as the active thrust, passive thrust, thrust in rest condition, or none of the above. So by your understanding, you can easily answer that the correct answer for this question. Okay, I will take the pen. Is option C. Sorry, option C, that is the thrust at the best condition. Because when we are going to construct any bridge abutment over there, as we are going to construct the bridge abutment over there on the specific sections or the pulls which or the supports which are there, there is the soil around there and there is no that type of pressure. The pressure on the soil from the all directions is applied equally, so neither that wall or the supports is moving toward the soil, toward the backfill or away from the backfill. So the thrust in at rest condition, when we read the explanation, it says also that it is at rest. The earth pressure exists when the wall system is rigid, that is when no movement is occurring as in the case of the deep basement wall or the U-shaped abutment bridges. So these are the aspects which we came across when we talked about this problem. I think so you developed the understanding what we are talking about. That for the design of bridge equipment, there is the no active thrust, no passive thrust. The thrust in at the rest condition, the aspects is also get discussed that why it is in the rest condition. Okay, okay. See, now we are moving to the next problem. The next problem states that a vertical wall of 6 meter height. Okay, where is my pen? Okay, the wall of 6 meter height. You underline the important things. Above the water table retains a 20 degree soil slope. The retained soil has a unit weight of 18 kilonewton per meter cube and approximate shear strength parameter C equal to 0, phi equal to 40 degree. The coefficient of active earth pressure used to estimate the active pressure conditions. So over here, what is mentioned? I will write first of all, height is mentioned, that is nothing but 6 meter. Okay, height is 6 meter. After that, most important things which we have discussed today only, retains a 20 degree soil slope. So this is telling that we have the value of beta as 20 degree. Okay, and the value of C as 0, phi as 40 degree, C is 0 and phi is 40 degree. So we have to calculate the coefficient of active earth pressure, that is Ka, as the question state over here. The coefficient of active earth pressure is used in estimating the active pressure acting on the soil is. So the we know the relation of Ka as, I will write cos beta minus cos beta minus root under cos square beta minus cos square phi, cos square beta minus cos square phi upon cos beta plus cos beta plus cos square beta minus plus cos square phi. Okay, so when you know the value of beta at 20 degree, you know the value of phi at 40 degree, and value of c is 0. So when you calculate k as cos beta minus root under cos square beta minus cos square phi by cos beta plus root under cos square beta plus cos square phi, cos square beta minus cos square phi. Sorry. Then you are able to calculate the value of Ki coefficient of active earth pressure for this condition. Now you see solution is also mentioned over here. See the relation is same which we have written in the last page. That is cos beta minus cos square alpha or phi whatever you say, and the cos beta plus root under cos square beta minus cos square alpha. And when you calculate it, you are able to get the value of K as 0.25, which is going to be our answer. Right? Yes. Now see, we are moving for the next question, which state that the the for the determination of earth pressure coulomb wave theory assume that backfill the back of the wall is smooth and vertical, whether it is true or false. The soil is non-homogeneous and anisotropic, whether it is true or false. The slip surface is circular, the wall surface is rough. So answer is very simple for this problem, and that is going to be D, that the wall surface is rough. So for the determination of Coulomb's pressure wave theory, the assumption is wall surface is rough is the assumption. When we say wall is smooth and vertical, this is wrong because wall is not smooth, it is rough. Soil is non homogeneous and anisotropic, it is also good. Wrong, soil is homogeneous and isotropic. The slip surface is not circular. It is, I think so, log spiral. I don't remember exactly, but I remember. See, so we have the answer with us that is the wall surface is rough, which is also get eliminated when we talk the Rankine theory. For the Rankine theory, wall surface is rough is the wrong answer. Okay, so this is a simple problem. Now we are moving to the next problem, which state that the wall shown in the figure has filled. The cause of failure or the error made in the design of the field wall is. Okay, so over here you see the width coil is shown over here. The top width is 0.2 meter, bottom surface for soil width is 1.2 meter, and we see it gets filled. So what are the regions? So the first option is mentioned over here is that the deep sleep failure, overturning, no proper drum drainage in the clay backfill, or the transparent failure. So from the question, it is very much clear that this over there the deep surface failure has though no meaning, translational failure is no meaning, overturning is also not associated with that. So our answer for this problem is going to be option number B. Oh, sorry. I think so. I have read something else. So option number B is our correct answer, that is overturning, and the explanation for that the outward motion is resisted by sliding resistance along the base of the wall and by the passive resistance of the soil lying above the two. The wall the active thrust also tends to overturn the wall around the toe. That's why the failure takes place. Again, I will read and then explain because something is very much important concept is hiding over here when we are discussing this problem. It says that the outward motion is resisted by sliding resistance along the base of the wall and by the passive resistance of the soil lying above the toe of the wall. The active thrust also tend to overturn the wall around the toe. Okay. So you get the understanding why the overturning is the answer? Yes. Okay. Now see. Now we are moving to our next problem, which state. Okay. Now we are moving to our next problem, which state that the Coulomb's theory of the earth pressure is based on. So there is the theory of elasticity, there is theory of plasticity. So we are going to discuss those things over here. Okay, okay. I think so. I'm audible. There is no network error. Yes, that's what I want to check. Yes. Okay. So over here, you see, when we talk about the Coulomb theory also sometimes says that the Coulomb wave theory. So first of all, I have given you this idea. Now read this problem. This is a multiple choice question asked in the GATE examination. Over there, the question says that the Coulomb theory, and this is the 1 mark question. As you know, there are the 65 question in the GATE examination, and out of which some question are of the 2 marks. That number is 35, and the 30 question of 1 mark. So this is a 1 mark question over there. We state that the Coulomb theory of the earth pressure is based on the theory of elasticity, theory of plasticity, empirical rules, wave theory. We have understood the Coulomb wave theory during the previous class. Is there any empirical relation mentioned over here? Over there? I think so. No, I am not able to see any empirical relation during that class. So I hope you get the very best understanding while answering this question that the answer of this given problem is going to be option number D, that is our going to be our right answer. Okay, so that is best. When we read, it says that the Coulomb considered the equilibrium of the entire wave. He assumed that the wave act as a rigid body and the friction is distributed uniformly on the rupture surface. So option D is going to be our correct answer. Now we are moving to our next problem. We say that the depth of tension crack in the soft soil is 4C by gamma, 2C by gamma, C by gamma, Cu by 2 gamma. So I think so. You understand these things. Okay, I will draw one diagram like this. You know that when cohesion is there, there is some negative earth pressure, and afterwards, the earth pressure diagram is made like that, and the intercept over here is 2c root k, 2 into c into root k. Okay, so the depth of tension crack is this much, and this much. So depth of tension crack in soft soil is going to be 2c by gamma as phi equal to 0, as phi equal to 0 for this case, phi equal to 0. So Ka that is 1 minus sine phi upon 1 plus sine phi. I will write that 1 minus sine phi by 1 plus sine phi. Okay, I will need eraser. Why it not working? Sorry. Okay, 1 minus sine phi by 1 plus sine phi. Okay, so for phi equal to 0, 1 minus sine 0 by 1 plus sine 0 is going to be 1. So our answer is going to be depth of tension crack as 2c by gamma root k. K A value is 1. So correct answer for this problem is 2c by gamma. That's the option B. Okay, you see over here, as it has been mentioned that PA equal to K gamma Z minus 2C root K. The ZC equal to depth of tension crack, and for Z equal to ZC, PA equal to 0, and when we put it in the first equation, that is PA equal to K gamma Z minus 2C root K. So for PA equal to 0, K gamma ZC minus 2C root k. When we solve for ZC, we find 2c root k upon k into gamma, and when the k is um, put down, it's come to be 2c by gamma root k, as for phi equal to 0, k equal to 1. So our answer is going to be 2c by gamma, that is mentioned over here, is the correct answer for the given problem. Right? Right. Now we are moving to the next question. We say that in the cohesive soils, the depth of tension crack ZCR is likely to. Okay, we know depth of the tension crack from the previous question. This is the revision of the question in the other fashion. What we know, first of all, we know Ka equal to tan square 45 plus 5 by 2. K equal to tan square, tan square 45 plus 5 by 2. I think so, you know. Okay. So, as over here we know depth of tension crack Z as depth of tension crack as 2c by gamma root k. Now k equal to tan square 45 plus 5 by 2. When it comes out of root, it become 2c by gamma tan 45 plus 5 by 2. Sorry, k equal to cot square 45 plus 5 by 2. I think so. Where is n? So this is going to be our correct answer, and over there some correction needed. Okay, I will take the pen again. Cot square 45 plus 5 by 2. So when cot square 45 by 2 is written over here, it become cot 45 plus 5 by 2. When it's turned upside, it become 2c by gamma tan 45 plus 5 by 2, which is our correct answer. Right? Right. Now we move to the with the same solution is written over here. I have given the explanation so that you get understanding of it. Okay. Now we have a next question. Over there, it is asking that the total active thrust on a vertical wall of 3 meter height. Okay, over here you see that the wall height is mentioned as 3 meter, retaining a horizontal sand backfill. Unit weight is 20 kilonewton per meter cube. The angle of shearing resistance, that is phi, is 30 degree. When the water table is at the bottom of the wall will be, so you know total active thrust relation for this as 1 by 2 into K into gamma h square, 1 by 2 into K into gamma h square. By this manner you are able to find the answer. Now over here the value of k is going to be 1 minus sine 30 upon 1 plus sine 30. 1 minus sine 30 upon 1 plus sine 30. 1 plus sine 30, which is going to be 1 by 3. Okay, so from here it's going to be 1 by 2 into 1 by 3 into gamma, that is 20, into height is going to be 3, that is square is 9. So when we calculate 9, 3 3 जा 9, 20, 10 हो गया, तो 30 किलो न्यूटन पर मीटर. Okay. So over here, what we have calculated, the total active thrust acting on a vertical wall, 3 meter high retaining wall, horizontal and backfill in gamma equal to 20, angle of internal friction is 30 degree. We have calculated the value of total active thrust, that is 1 by 2 into k into gamma h square, where k equal to 1 minus sin phi upon 1 plus sin phi, as phi equal to 30 degree, the value of k is going to be 1 by 3. And when we calculate the total active thrust as 1 by 2 into k gamma h square, it become 1 by 2 into 1 by 3 multiplied by gamma is 20 into h square is 3 into 3, that is 9. When we calculated those, we find that the value is coming to be 30 kilonewton per meter, which is going to our correct answer. So the option number A is the correct answer for the given problem. When you see the explanation, the similar diagram has been shown over here. The PA is found, which is acting at h by 3 above the ground. Its height is 3 meter. So 1 meter is nothing but h upon 3 from the base of the ground. For this condition, this is a very standard condition. So first of all, we have calculated k, then we have calculated 1 by 2 into k gamma h square, and finally we get the answer. Right? Okay. So before moving ahead, we will take a small break over here of the 5 minutes, and we will start after the break. Okay. So I will write over here a 5 minute break. Okay. So we will see you after 5 minutes. Hello, hello. Welcome back, everyone. I'm audible? Yes. Okay, so we are discussing about the some of the problems associated with the subjects. And as we go before the break, we are discussing about the question related to the total active thrust. And we have solved this problem and get our understanding about the things which we are taking it over here. Now we move to the next problem and go step by step and solve some of the very good problems which are asked in the many of the specific examinations. And at the end, uh, we will see that what are the different aspects we will looking into it. Okay, so I am starting again. So the first question after the this small break is that the cohesion in soil decreases the active pressure and increases the passive resistance. Decreases both active pressure and passive resistance. So there are the only two options over here for this problem. As you know, first of all, you know the interrelation for the active earth pressure and the passive earth pressure. So first of all, you write that and you get the answer from that equation only. As you know, the value of Pa is Ka into gamma j, Ka into gamma j minus 2c root K minus 2c root K. Similarly, The value for the passive earth pressure is given as Kp into gamma j plus 2c root k. Now read the question very carefully. As you read the question, what it states, you get your answer without any confusion. It says the cohesion in soil decreases the active earth pressure and increases the passive resistance. As you see, this cohesion factor decreases, subtract from K gamma Z, so it decreases the active pressure. And when we talk about the passive resistance, this 2C root Kp added to the Kp gamma Z, so it increases the passive resistance, it increases the passive resistance, it decreases the active resistance. So our answer is the cohesion in soil decreases the active pressure and increases the passive resistance. So just when you know the relation, when you write the relation without any doubt, you can answer the question for the given problem. I think so there will be no doubt regarding the same. Okay. Now, as you see over here, the written same thing. So that's not a issue with anyone. Now we will move to the next problem. Next problem says that to have a zero active pressure intensity at the tip of a wall in a cohesive soil, one should apply the uniform surcharge intensity of. It's a zero active pressure intensity at the tip of the wall. Basically, at the wall, at the top of the wall, if we need the zero intensity of pressure, the one should apply the uniform surcharge. Basically, what it's saying, I will write first of relation in the term of this. It say we know that PA equal to K into gamma z K into gamma z plus Q. Q is the surcharge. I is talking about surcharge. Gamma z upon Q. Here Q is the surcharge. I will not write a surcharge over here, so you understand that what is the meaning of Q. K plus gamma z minus 2c root K. Now it is asking that how much surcharge we should have so that the earth pressure diagram, which in general get formed like this, get changes from this to this. So if there is somewhat surcharge, this could be happen. So to get the value of PAH at 0 at Z equal to 0 or PA equal to 0. Okay. At Z equal to 0 for PA equal to 0 we write 0 equal to KA into gamma Z is there, so 0 plus PA minus 2c root K. When we solve it, it's going to be 2c root k 2c root k go on the opposite side and it's become 2c root k upon k, that is okay. From here I will take a one page. This side. Okay. As above you see that 0 equal to k 0, okay, I will write 0 equal to k into k into 0 plus PA minus 2C root K. So this become K into PA equal to, sorry, PA not Q. Okay, eraser. Yes. Eraser is not working. What's the problem? Okay, that's not the problem. I'll write on the next slide and you understand from here only. Since QA, K into Q. QA is the surcharge equal to 2C dot K. So QA equal to 2C divided by root K. And we know K equal to cot square 45 plus 5 by 2. Cot square 45 plus 5 by 2 is cot square alpha. So 2C tan alpha. That is going to be this option A. Option A is our correct answer. Okay. You can see that how we have solved by step by step. Yes. Now you see, we are moving to the next problem, which is a very important problem in this aspects, and it state that a breast cut of 5 meter wide, 7.5 meter deep is proposed in the cohesionless soil deposit, having the effective cohesion C as 0 and the effective friction angle phi at 36 degree. The first row of the stud is to be installed at depth 0.5 meter below the ground surface, and the spacing between the studs should be 1.5 meter. If the horizontal spacing between the studs is 3 meter and the unit weight of soil is 0. Is 20 kilonewton per meter cube, the maximum stud load will be. Okay. So the what are the important things which is mentioned over here? You see, first of all, it is mentioned at the 5 meter wide, 7.5 meter deep. Proposed in a cohesion-less soil, that is C equal to 0 and phi equal to 36 degree. The first row of stud is installed at 0.5 meter below the ground. Okay, this is also mentioned. And the spacing between the stud is also mentioned as 1.5 meter. And if the horizontal spacing is 3 meter, gamma is mentioned 20 kilonewton per meter cube. So we know 0.65 into K gamma H is the uniform pressure on a side cut. So we know that the first distance below the ground is start one is at the 0.5 meter below the ground. Now we first of all calculate the uniform pressure on the side cut, that is the 0.65 into K gamma H. Now as the value of phi is given, that is the 36 degrees, so we calculated the value of K as 0.2596, that is 0.26. Okay. Now, we are interested in finding the uniform pressure on the side cut first of all. So, we have calculated the 0.65 multiplied by K, that is 0.2596, and into gamma E20 is given to us into height, that is a 7.5 meter, we now know the uniform pressure on the side cut is 25.31 kilonewton per meter square. Now we also know the area is we get by multiplying 3 into 0.5 plus 75. There are the two aspects are getting developed over here. The first distance is the 0.5 and the second half distance is 0.75. This distance, when we calculate at its half, and from here we are going to get the value is 0.5 plus 0.75, that is 1.25. Afterwards all other distances are equally distributed as 1.5. This distance is going to be 1.5. So two aspects we are getting over here. Either multiplied by 1.5 into 3, what we get as 0.65 k gamma h, or multiplied it with 0.5 plus 0.75. So we have found the area as 3.75. Um, we found the first area of the cut as 3.75 meter square and second is 4.5. As the value of 4.5 is the maximum, so we are interested in getting the maximum force. So we multiply 25.31 is 4.5 and we get the value as 113.89, that is 113.90. So we are our answer is 113.90 is our correct answer. I think so. This concept is very much clear with you because we have discussed this in very brief in the class. Sorry. Over here we are carrying it forward in the true sense. Okay. Now see what is coming next for you. So next question is over here that an unsupported excavation is made to the maximum possible depth in clay soil having gamma T as 18 kN per meter cube, C as 100 kN per meter square, phi as 30-degree active earth pressure according to Rankine theory at the base level of the excavation is. Okay. Okay, so this is a very simple problem. First, as I say, mark the important things. So first important things is mentioned that the unsupported excavation is made to the maximum possible depth. Maximum possible depth in a clay soil having gamma T as 18 kN per meter cube, C as 100 kN per meter square, phi is 30 degree. Active earth pressure according to Rankine theory at the base level of the excavation. So first of all, we have to know the maximum depth of excavation. So maximum depth of excavation without the support is Z equal to 4C by gamma root K, 4 into C upon gamma into root K. As we know, value of C over here as 100, so 400 upon gamma. Gamma is nothing but 18, so 18 into root K is 1 by 3, so it's multiplied by root. When we do this calculation, we are able to find the value of Z, whatever we, okay, when we do this calculation. Now, as you know the value of Z, now we have to calculate the active earth pressure according to Rankine theory at this step. So, how you calculate this? Now, you will calculate this as active earth pressure PA as in K into gamma Z, the Z which you get from here minus 2C root K. Now, I will take a calculator and calculate these things for you. So first of all, what we need to calculate the value of we need to calculate the value of Z, right? So value of Z is going to be 400 upon 18 multiplied by root 3. Okay. Okay, we can calculate in another way as well. See, as we know, the value of Z is going to be 38.49. Now, when you are going to calculate this, you will do the calculation as K as 1 by 3 into gamma is 18 to 38.49 minus 2 into 200, 2 into 100, 200 upon root K 1 by root K. Okay, so I will um, multiply it with 6 minus, oops. So option number 115.47, we are going to get answer as 115.47. 115.47. So this is going to our correct answer. Okay, I think so things are clear. Again, I will explain. So first, it's asking that an unsupported excavation. Unsupported excavation. So we know from the Earth pressure theory that the maximum unsupported depth is 40 by gamma root K. Up to that, there is no support is needed. Only excavation could be done up to that depth and it will stand up to that depth. So we know this thing. The thing which we don't know that the active earth pressure according to Rankine earth pressure theory, they is asking at that depth. So first of all, we are interested in getting the depth up to which it withstand without any support. So first of all, we get that fact. How we get those things? By multiplying it with with by getting the 4c by gamma root k. So 4c by gamma root k is nothing but 4 into 100, that is 400. By gamma is 18, root k is 1 by 3. When it go upside, it becomes 400 root 3 by 18. And when we calculate that value, we get z as 38.49 meter. Now we are interested in getting the earth pressure at that depth in kilonewton per meter square. So we know the relation as K gamma z minus 2c root K, where K is 1 by 3 as phi equal to 30 degree, gamma is 18, z equal to 38.49, which we have calculated, minus 2c equal to minus 2 into 100 by root K. 2c root K is equal to divided by root 3. When we do the calculation, we are able to get the answer as 115.47, which is going to be our correct answer. This they also are solved in another manner. You can go across these as well, but that doesn't important. What I have solved, you can go see this only, and that will be sufficient. Okay. Now we are moving to the next problem. Next problem here state that a retaining wall of height 8 meter retains the dry sand. So height 8 meter is important. Retain a dry sand in the initial states while loose soil is loose and has a wide ratio of 0.5. Wide ratio means E gamma D is 17.8 kilonewton per meter cube and pi is 30 degree. Subsequently, the backfill is compacted to a state where wide ratio gets changed to 0.4. Wide ratio is 0.4, gamma D is 18.8 and phi 35 degree. The ratio of initial passive thrust to the final passive thrust according to Rankine earth pressure theory. So this is nothing but you have to calculate first in the first place case 1 plus sine phi upon 1 plus sine phi by 1 minus sine phi. First of all, calculate 1 plus sine phi by 1 minus sine phi for phi equal to 30 degree. Afterwards, calculate 1 plus sine phi by 1 minus sine phi for phi equal to 35 degree and take the ratio for those and you will get a value that will be going to be the ratio of passive. Okay, sorry. They are asking the ratio of initial passive thrust to the final passive thrust. Okay. So you have to calculate the Kp for the both the case and afterward you have to calculate 1 by 2 Kp into gamma z square for the first case and similarly for the second case. Afterward take their ratio and you will get the answer. So I will explain this over here as it is solved. So you see, first of all, we have calculated the value of Kp as for phi equal to 30 degree as 3 and then we calculate Pp1 as 1 by 2 into Kp into gamma h square which we get as 1708 kilonewton per meter. Now we calculate the Kp for phi equal to 35 degree and we get the value as 3.69 and we calculate Kp as 1 by 2 into Kp into gamma h square which we get as 1 by 2 into 3.69 into 18.8 into 8 square as 2219.90. Now we are interested in getting the ratio of PP1 to PP2 which is going to be get as 0.77. So 0.77 C, option number C is going to be our correct answer. Okay, I think the things are clear up to here. There will be no doubt regarding the same. Okay, we can move ahead. Okay, so we are discussing the things regarding that a 3-meter high retaining wall is supporting. Sorry. Okay, so we are discussing the things about the some of the problems, questions, and conceptual clarity we have already with us. So we are solving problem as you have seen up to this. We have solved the many questions and we got the critical solution about the things as a second last problem from now which we solved where we are able to calculate the depth of unsupported depth and afterwards at that depth what will be the active earth pressure we have calculated with the E. So question could be framed in that direction. Over there actually that is a 2 mark problem of the GATE examination. Over there, you have to calculate the two things in a simulated time, and as one question is hardly having 3 minutes or less than 3 minutes in those competitive exams like GATE, or when we calculate in those in the engineering service, the time is more less than that what we have. So you need to be able to understand the concept, analyze, summarize, and solve the problem in the given simulated time to get the best output. Otherwise, you will get suffer if you are not able to do so. Now the next question over here in front of us state that a 3-meter high retaining wall is supported 3-meter high retaining wall is supported is saturated sand saturated due to the capillary action of the bulk density 18 kilonewton per meter cube. and the angle of shearing resistance at 30 degree, that is nothing but phi. Okay, and the change in the magnitude of active earth pressure at the base due to rise in groundwater table from the base of the footing to the ground surface, gamma w is this given as. So it is asking about the change in magnitude of active earth pressure at the base due to rise of groundwater table from the base of the footing to the ground. Okay, so over here the water table get rising. As we know, the relation as K into gamma jet, where gamma is the effective, and afterwards um, minus 2c root K is there, but cohesion concept is not there. Um, the height is 3 meter over here, and it's K into gamma z. First of all, K is 1 by 3 into gamma is 18 into 3. Afterwards, as water table rises, it's subtracted by the answer is going to be option number C. As you see, first of all, as phi equal to 30 degree, we have calculated the Kp as 3. Afterwards, okay, see, we are discussing the hello. Okay, sorry. So what we are taking, or which question we are discussing? Okay, sir, there are some issues regarding some technical issue over here. That's why we are not focused up to here. Okay, sorry. Now we take the question. So over here, the figure given below. So a smooth vertical gravity retaining wall with a cohesionless soil, the backfill having the angle of internal friction phi. In the graphical representation, the Rankine active earth pressure for the retaining wall in the figure length OP is represent the vertical stress at the base, the vertical stress at height h by 3 from the base, lateral earth pressure at the base, or h lateral earth pressure at height h by 3 from the base. So over here you can see the beta is represented, the sand as a backfill is represented, the Mohr envelope is formed, and the ground line is also shown, Mohr envelope is also shown, and this question it is asking that from the figure given below shows the smooth vertical gravity retaining wall with the cohesionless soil, as it is shown that the line which Mohr envelope so is drawn from the origin. So the value of phi is only there, the value of angle of cohesion is not there because on the shear intercept the value is going to be 0. So now question asking the graphical representation of the Rankine active earth pressure on the retaining wall shown in the figure. The length OP represents the vertical stress at the base or the vertical stress at h by 3 from the base, the lateral earth pressure at the height at the base, the lateral earth pressure at h by 3 from the base. So as it is already represented as a ground line, so you understood the option is A is going to be our correct answer, as you have seen from this picture which is mentioned over here, which state that the value of Mohr envelope is the tangent from the origin, and the beta which makes with the horizontal is the ground line, and the option A state that the vertical stress at the base it is representing, which is shown on the Mohr circle as given below. So the tangent in the upper and lower direction both are drawn, and the intercept is also shown at point R. So the active condition is represented with this case. Now you see the second problem which is mentioned here with. A question state that a smooth rigid retaining wall moves as shown in the figure, causing the backfill material to fill. The backfill material is homogeneous and isotropic and obeys the Mohr Coulomb failure criteria. The major principal stress is. So over here we can see that the initial wall position is first of all at is also presented, and the final wall position is also presented as the wall is moving toward the backfill in one way or the other, and it is asking the major principal stress is whether parallel to the wall face acting downwards, normal to the wall face, oblique to the wall face acting downward, oblique to the wall face acting upward. So it is very much clear in anyone's mind, and I have discussed as well at many times. As wall is moving toward the back face, the major principal stress is normal to the wall face. So option number B is going to be our correct answer. Let's see. Yes, over there you can see the option number B is also popping up, because see the explanation I will also mention here. You see, when in any condition as this condition depends, as the wall is moving toward the soil. Initial position, it's a little bit at a different position, which is away from the soil in one way when we compare these two images of the initial position and final position. So as the wall moves toward the soil, it's bound the soil over there, and it's comply the horizontal stress. It increases the horizontal stress, horizontal forces. So resultant horizontal forces increment resulted in increase in the stress in the horizontal direction, and the vertical stress is due to the gamma jet which is already there. But as over there the wall moves toward the soil, the horizontal stress get resulted in the increase in stress. So this direction will become the principal stress direction. Similarly, if the condition is reversed, the final position is the initial position and the initial position is the final position. For that case, the wall is moved away from the soil in the second condition. For that condition, the soil get relaxed, released in the stress in that direction. So that direction in that case become the minor principal stress, and the stress in the vertical direction due to the gamma jet is going to be major principal stress. Okay, so things will be clear up to this. Now we will move ahead. Okay, so I think so. Something missing? No. Right. Now you see the next thing is this question. This question states that the two soil profile unit as a backfill behind the retaining wall as shown in the figure. The gamma T, the total unit weight, C and phi are the effective shear parameter. Find the resultant active earth pressure in kilonewton per meter. This is the most interesting problem up to this time. So over here, first in the first layer, uh, K K value. I will calculate everything over here with myself. Answer is there in the next page, but when I calculate with myself, the understanding will be better. K equal to 1 by 3 for pi equal to 30 degree. And over here, the value of K for pi equal to 40 degree is going to be, anyone can tell? In the meantime, I will calculating as well. I will like to hear from you, but I will calculate myself as well for a while. Okay, what I get 0.217, 0.217. Okay, right? Now we are interested in getting the value as like this. You see, first of all, the first 2 meter is there, then the second 2 meter is there. So at mm, first of all, E equal to K A into gamma Z minus 2C root K. Okay, for the first layer, of soil, mm, E equal to 1 by 3 into gamma, that is 15, and Z minus 2C root K. I see 0, so I will write up to this. So this is going to be 5Z. Okay, and for the layer 2, C is only 0, second layer, A is going to be 0.217 multiplied by 15 to a 30 plus 20, right? Now over here, from here, at Z equal to 0, E equal to 0, and at Z equal to 2, E equal to 10. Now over here at Z equal to 0, over here at Z equal to 0, E equal to what? And Z equal to again 2, E equal to what? We are interested in this, and after calculating those area, we are going to get our value. So at Z equal to 0 over here, 30 into 0.217. Next, give me a second. I will calculate 30 into 0.217 at 06.51. So we will draw the diagram as well. So this is 10, then this is 10, this is 6.51. This is going to be at 20 into 2, 20 into 2 plus 30 into 0.217 is 15.19. Area is our answer. Area is going to be answer because this is asking in that manner 6.51 and 15.19. Over here, when you calculate the area, you will get as 15.19 plus 6.51 divided by 2 into 2 plus 0.5 into 10 into 2. Okay, remember 15.19 plus 6.51 31.7. So we have plotted, we have drawn, and we found the answer at 31.7 is going to be our answer. So I will explain it for a while to give you good understanding of the things which we are going with. As you see over here, the question has asked given the two soil profile. First of all, we have no relation PA K into gamma J minus 2C root K. For the first layer, we have calculated the value for the first layer. We have calculated value as 1 by 3 into K gamma J. Sorry, K into gamma J. K equal to 1 by 3 and gamma is 15 and Z is Z. So we found 5Z and at Z equal to 0, PA is 0, which is plotted over here as 0. And at Z equal to 10, PA equal to 10, which is plotted over here as 10. After that, when we go into second layer, it is the K 0.217 into 30 plus 20 Z at Z equal to 0. Again, we get the value as 6.51, which we have plotted over here. And at Z equal to P 2, we the value is P equal to 15.19. When we plot this and found the area of this section, we get area at 31.7, and that is going to be our answer. Right? I think so. Things is very much clear, which they have done as well, and provided the solutions. So that's not the thing which we need to discuss. That they have calculated first of all the key value for the first layer, then second layer, then they have found the area. The things which we have done, the same thing they have done, and when they calculated, they found the answer as 31.7, which we also found. Sorry. Okay, so what we are doing currently, we are solving the problems of the different aspects which we have with, and we will move in the same way up to the end. We have some questions with us. Okay, no problem. We will solve it out into the class only. Okay, so the surcharge loading required to be placed on the horizontal backfill of a smooth retaining wall so that completely eliminate the tensile crack. I think so. This question is we already solved earlier as well, where we come to know that this value is going to be 2C root K, and how we have done this. You are very much aware. So see if things are there. Okay, so we know K multiplied by gamma z plus q as surcharge minus 2c root k. As we want to avoid the tension crack, we want z naught as 0. So we say at z equal to 0, what should be the value of q? At z equal to 0, what should be value of q? So that is going to be Ka multiplied by q equal to 2c root k. And when we calculate q, it's we get as 2c upon root k, right? That is the thing which we get 2c upon root k. Option number D is the correct answer. This is a one more question from the GET examination, right? Now we are moving to the next problem. Next problem says that a 6-meter high retaining wall having a smooth vertical backface retains a layered horizontal backfill. Top 3-meter thick layer of backfill is sand having angle of internal friction phi at 30 degree, while the bottom 3-meter thick layer is with cohesion C equal to 20. Assume unit weight of both sand and clay as 18 kilonewton per meter cube. The total active pressure per unit length of the wall. Okay, this is going to be most interesting problem. So I will first of all draw the problem for you. Over here is 6-meter high retaining wall. This is 6 and layered horizontal backfill top 3 meter. This is top 3, this is bottom 3. Top 3 meter thick backfill is sand having phi equal to 30 degree. Phi equal to 30 degree. So Ka equal to 1 by 3. Okay. And bottom layer is 3 meter thick with C equal to 20. Assume unit weight both for gamma equal to 18 for both. Gamma equal to 18. Over here C equal to 20. Now see one important thing. We write PA as 1 by 3 into 18 into Z, that is 6Z. Then I plot a graph. It is going to be 0 at the top and 18 over here. Now for the bottom layer, we write PA as K is not mentioned, is phi not mentioned, so K is 1 for phi equal to 0. And the top 18 3 ja 18 2 ja 36, 18 3 ja 54, 54 plus 18Z. I think so the things are clear when I have solved the last problem. It is solved in the similar manner. Minus 2C root K C 20 and K is 1 only. So this is also going to be 54 minus 22 is 14. 14 plus 18Z. For Z equal to 0, this value is going to be 14. And for Z equal to 3, 18 3 are 54, 58, 68. This value is going to be 68. And this is 14. When we calculate the result, we are getting 68. Give me a minute, I will solve using calculator. So I am getting 68 plus 14 divided by 2 multiplied by 3. Sorry, something mistake I have done. 68 plus 14 equal to divided by 2 equal to 68 plus 14 into 0.5 into 3 plus 0.5 into 18 into 3. So the value is we are getting as 150. The result A area equal to 150 kilonewton per meter. So the correct answer is going to be option number A, that is 150 kilonewton per meter. See, 150 kilonewton per meter is the correct answer. Okay, so I will explain it again. You see, first of all, the question state that it is a 6 meter retaining wall. It has a different property for the top 3 meter layer and the bottom 3 meter layer. So first of all, we have calculated the value of retain the value of pi as 30 K as 1/3, and we have write the equation as of PA as K gamma Z, that is 1/3 into 18 into Z, that is 6Z. For Z equal to 0, the value of PA is going to be 0, and for Z equal to 3, the value of PA is going to be 18. Now similarly for the second layer, as phi is not mentioned, so we assumed phi as 0. So K is going to be 1. We have write the equation over there as well. K into gamma Z, K equal to 1 into gamma Z, that is first for the first layer 18 3 are 54 plus 18Z plus minus 2C root K, as the value of C 20K is 1. So its equation going to be 14 plus 80Z. Now putting at Z equal to 0 in the second for the second layer, the value is getting 14, which is plotted in the graph in the right side part of the diagram. Afterwards, when we are getting for Z equal to 3, the value is getting 68. When we found the area of this section, we found area as 150, that is going to be 150 kilonewton per meter. That is the total active pressure per unit height of the wall. We can also calculate its location as well by solving the by getting the different area and dividing from the bottom section that how much at what section it is applied. Okay, I think so. Things are clear, right? Now we are moving to the next problem. The next question say that a vertical cut is made in the soil mass having a cohesion C, angle of internal friction phi, unit weight gamma, considering K and as the K as the Kp as the coefficient of active and passive earth pressure respectively, maximum depth of unsupported excavation. So you know for the active earth pressure K, maximum unsupported depth is 4C by gamma root K. We have done many times. We have also calculated, derived in this class only in the different problems. So option number D is the correct answer. I am not going to discuss it again over here. See, option D is there. We have discussed this, we have derived this in this section only. Now see the next problem. Next problem is also one of the interesting problem. Let's see how much time we needed to solve the different problems which we have with. Okay, there are some problems remaining. Let's see. If we could, we will solve. Okay, over here you see again. The question is mentioned that the soil profile at the site consists of 5 meter thick sand layer. The diagram is also mentioned. 1 meter top bulk unit is different, 4 meter is different. And the C5 soil as shown in the figure, the bottom of the water table is found at 1 meter below the ground surface. Okay, okay, very good. The entire mass is retained by a concrete retaining wall and is in the active state. The back of the wall is smooth and vertical. The total active pressure kilonewton per meter square at point A. So this is not a difficult problem. This is a very simple problem. Only you have to first of all take your pen and found the value of K for the second layer over there phi equal to 24. For phi equal to 24, as it is asking the total active earth pressure phi equal to 24, phi equal to 24, value of K is what? I need an answer. I think so. I only can give the answer for this. Okay, I will take the answer from the here. K 0.4217. K 0.4217. Now we will write the equation for PA. So what is the PA? PA is K into gamma Z minus 2C root K. 2C root K. Over here you see this value is going to be 0.4217, 0.4217 multiplied by first of all 16.5 into 1, Then gamma sat is 19 minus 9.81 plus 19 minus 9.81 multiplied by 4 plus 18.5 minus 9.81. 18.5 minus 9.81 into 3 minus 2c root k. The value of c is 25 and root k is 0.4217. So what will be answer? So when you solve this, you will get the answer. The stress at point A is 69.65. 69.65. Okay. So what we have did, we have found the value of k for this layer. Then k into gamma z for the gamma bulk is 16.5 into 1, then 19 minus 9.81 into 4, then 18.5 minus 9.81 into 3, and then we subtract minus 2c root k where c equal to 25 and root k is again 0.4217. When we calculate this calculation, we find the value of 69.65, that is kilonewton per meter square will be the active earth pressure acting at the point A as asked in the problem, which they have solved as well. So I don't think I need to elaborate again over here. Now we are moving to the next problem. Next problem states that the consider a rigid retaining wall with a partially submerged cohesionless backfill, as backfill is cohesionless with a surcharge, which one of the following diagram closely represent the Rankine active earth pressure distribution against the wall. So as the surcharge is there and the cohesion less is there, so due to the surcharge, K into Q plus gamma Z at Z equal to 0, some value should be there. So the option number A is eliminated, option number D is eliminated. So option number B and option number C could be the potential answer. But as you see, the surcharge is there, but in option number C, this is uniform up to up to some depth, which is not the possible because from Z equal to 0 as we increase, it will become some linear graph. So option number B is going to be our correct answer, as you see. Right? Now we are moving to the next problem. Over here, a question is there that a rigid smooth retaining wall of height 7 meter with a vertical backfill retain a saturated clay as a backfill. The saturated unit weight of the and the undrained cohesion are 17.2 and 20 kilonewton per meter square. The difference in the active lateral earth force on the wall kilonewton per meter length up to two decimal place before and after the occurrence of tension crack. Okay, so this, as you know, when you draw the graph like this, you plot everything, you get the graph like this. Okay, so you know the value of this and this for 2c by gamma root k and 2c by gamma root k is similar, and tension crack is up to depth this. So over here when you calculate, first of all, this area you found, this area you found useful when tension crack is not there, and when tension crack is there, when you plot the similar graph, when you plot the similar graph, this area is useful. So when you subtract these two, this value is going to be your answer. You see the solution only, because time is going ahead. So you see over here. So first of all, they plot the graph. Earth pressure when the tension crack are developed, so the upper and lower section get removed. And when tension crack is not there, the first graph is found, then the second graph is found. When we subtract those value, we get the value as 46.76 7262 as our answer, which we are in search of. I think so. This understanding is clear. The earth pressure when the tension crack develop, we can consider this much area because this thing is cancelled. When tension crack is not there, this area get cancelled. Only this much area is because this is positive, okay, and this is negative in the equal amount. So this much area is there, which they calculated over there, as you see. And when tension crack develop, the value will be more. When we subtract second from first, we get the value in the negative of 46.7262. Okay, I think so. Things are very much clear for everyone. Now we move to the next problem. Over here, the question is there that a 3-meter high vertical earth retaining wall retain a dry granular backfill with the angle of internal friction of 30 degree, means phi equal to 30 degree, k equal to 1 by 3 unit weight 20 kN per meter square. Why the wall prevent from melting, no movement, the total horizontal thrust in kilonewton per meter square. So okay, 1 by 2 into k gamma is h square divided by into divided by h by 2, you find the answer. So you calculate first of all the rest condition is there. So k naught equal to 1 minus sine phi. Then we calculate 1 by 2 into k naught into gamma into h as 45 kilonewton per meter. So the option number C is the correct answer. Over here, some things are written that how we find it is in the rest condition. No movement is written, so no movement indicate that in the rest condition. Okay. Now, what are the output we gather from the today class is that we understood the earth pressure at rest, understood the Rankine earth pressure theory, we understood the active and passive earth pressure. We also come to know that how the problems get framed from the active and passive earth pressure or the earth pressure at rest, and those questions could be how we can take, how we find the depth of the tension crack, how we find the difference when the tension crack develop and the tension crack doesn't develop. We also come to know about the solution for the stratified layer of soil where the C and phi are both or only phi value is there. So we solved the very much standard question in this class. So some questions which you need to solve from this topic for the practice or the exams which you are going to take at the end of the session. So these are some references which you can refer for your solving the problems. So with this, I will sum up the today's session. Thank you everyone for attending this session. Wish you all the best for your learning and wish you a very happy weekend. Thank you everyone.